how to determine slope using similar triangles. We know how to find constant rate of change from a graph by putting the 2 points into a table, but now we are going to make triangles using points on the graph. So when you do this, you want to make sure that you pick points that you know are specific points. The way to do this is we're going to go to the left 2 and then up 4. This point right here falls on, the graph crosses through what I like to call a crosshair. The point is right here in the middle of where the grid connects. So I know specifically that that point is -2, +4. My second ordered pair that I'm going to use is -1, +2, because again, this is right on a crosshair. So when I look at these points, I have -2, 4, and -1, 2. I have to look and see which point is closest to the left. And that would be -2, 4. To get from -2 to -1, I'm going to decrease in my y value. This is like a downhill slope, or as we learned when we did our constant rate of change, we know that just by looking at this graph that this is going to be negative. So slope, just like constant rate of change, is rise over run. So to get from this point to -1, 2, I go up and down first. I established that I was going down, so I'm going to make one side of my triangle by going down 2 boxes. If I'm going down, that is negative. Then, to reach my other point, I complete the triangle by going over 1. -2 over 1 simplifies to -2. Now, because I'm drawing similar triangles, similar means they are not exactly the same, they just have the same shape, but they're going to be a different size. So I need to pick one more point, and I see a nice point right here at the origin. So I'm going to start back at my original point, and to get from -2, 4 to 0, 0, I'm going down 1, 2, 3, 4, to the right 1, 2. That simplifies to -2. So my slope is going to be -2. Let's look at the next one. We've got a point at -1, 2. And we have a point at 0, 5. This point is the one that's closest to the left. To get up here to 0, 5, I'm going up 1, 2, 3. So we rise before we run. I'm going to the right 1 space. So my slope is 3. I'm going to pick one more point so that I can make a similar triangle. I'm going to go to -2, -1, and I'm going up 1, 2, 3, 4, 5, 6. To complete the triangle, I'm going to the right 1, 2, which also simplifies 6 over 2. 6 divided by 2 gives me 3. So my slope is 3. For the next one, we have 0, 1, and we have 2, -2. 0, 1 is closest to the left, so I'm going from here down to here, so that means I'm going down 1, 2, 3, over to the right 1, 2. That is -3 over 2. I can pick one more point just to check. I'm at -2, +4. To go from up here to down here, I'm going down 1, 2, 3, 4, 5, 6. So that's negative 6. And I'm going to the right. 1, 2, 3, 4. 2 will go to both negative 6 and 4. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. Negative 3 over 2 is what I got the first time. So this is my slope, negative 3 over 2. And here we have, across here, a point here, as well as here. So to go from negative 4, negative 2, to negative 1 to 0. I'm going to start with the point to the left. And to go from down here to up here, that means I'm going up. So we rise over run. Rise 2, going up 2, to the right, 1, 2, 3. I could pick another point and come up here to 2, 2. Again, we start with our left point, and we go up 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5, 6. 2 will go to both 4 and 6. So I'm going to simplify that by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. That is the same thing I got the first time. So my slope is 2 over 3. And that concludes our review of finding slope for a graph using similar triangles.